Okay, 2.3 curve sketching. Sketch the graph of the quadratic function, graph of the cubics, quadratics, and the rational function. Okay, given the general form of the quadratic function f(x) equals to x squared plus bx plus c, and first step before you sketch the graph of the quadratic function, so you find the stationary point of the function using the differentiation method, or second here using the completing the square. Yeah. And step 2 here you find the intercept of the function, y-intercept and x-intercept of the quadratic function, and last you sketch the graph of the quadratic function. Okay. Okay, question 10. Sketch the graph of the quadratic function using the differentiation method. Y equals to the x squared plus 4x plus 1. Okay, first step, you find the stationary point of the quadratic function. Y equals to the x squared plus 4x plus 1, and you find the first derivative of the function, dy over dx here equals to the 2x plus 4, and you let the first derivative equal to 0, and the stationary point here exists. Okay, stationary point here exists when the first derivative equal to 0, 2x plus 4 equal to 0, and find the value of x. X here equals to the -2. Okay, and you substitute 2 here into the function, and the value of y equals to the -3, and the stationary point here at the -2, -3. Okay, and determines the relative maximum and the relative minimum point. Yeah. First row here you put the value of x, and second row here first derivative dy over dx, and the third row here is the shape of tangent, and the value of x here equals to the -2. Okay, -2, and then the nearest value from the left here equals to the -3, and this one -1. Yeah, and you substitute this value into the first derivative and determines the sign of the first derivative. So the second row here is substitute negative, this one is 0, and here the positive sign, and the shape of tangent here decrease, horizontal line, and here increase. Yeah. Okay, so using the first derivative test, the relative minimum point here exists at the -2, -3. Okay, or the second method to find the relative minimum point using the second derivative test. Yeah, first derivative 2x plus 4, and second derivative here equals 2. Okay, and sign of the second derivative greater than 0, and conclusion, you here the relative minimum point. Okay, and the relative minimum point here at the -2, -3. Yeah. Okay, and find the intercepts of the function. So intercept of the quadratic function, first find the y-intercept of the function. Okay, y-intercept of the function, x here equal to 0, so you find the value of x, value of y, and value of y here equals to 1, and y-intercept here at the 0, 1. Yeah, and the x-intercept of the function, y here equal to 0, and you find the value of x. So 0 here equals to the x squared plus 4x plus 1, and the value of x here equals to the -3.73, and x equals to the -0.27. Okay, and you sketch the graph of the quadratic function. Okay, first the relative minimum point. The relative minimum point at the -2, -3. So you label, and intercept of the function, y-intercept, and x-intercept of the function. Okay, so the y-intercept here at the 0, 1, and x-intercept -3.73, and -0.27. Okay, and then you sketch the graph of the quadratic function. Okay, so you labels the intercept of the function, y-intercept here at the 1, and x-intercept here at the -3.73, and here equals to the -0.27. Yeah, and you label the relative minimum point at the -2, -3. Okay, settle. Yeah. Okay, second method, to sketch the graph of the quadratic function. Okay, y here equals to the x squared plus 4x plus 1, and you complete the square. So the coefficient of x here equals to 4, x squared plus 4x, and 4 here divided by 2, and -4/2 and plus 1, and here equals to the x plus 2. Okay, and -4 plus 1 here equals to the -3. Okay, y equals to the x plus 2, power of 2 minus 3, and you compare with the general form of the quadratic function. So you compare with the general form of the quadratic function. H here equals to the -2 and k here equals to the -3. So the relative minimum point here at the -2 and -3, and the coefficient of quadratics here, a here equals to 1 and greater than 0, so graph here open upwards. Okay, and find the intercept of the function, x-intercepts and the y-intercept of the function. Okay, y-intercept x equal to 0, so find the value of y here equal to the 0, 1, and x-intercept here y equal to 0, find the value of x here equals to the -3.73 and x here equals to the -0.27. okay, and last you sketch the graph of the quadratic function.